Hi guys, this is Ms. Carranza. Today we're going to talk about 5.4 notes, part 2, day 2. For the rest of this chapter and this section in particular, we are going to focus only on radians and not degrees. I know that radians is not your favorite, but you need to be able to work comfortably between degrees and radians both. Do you guys remember what angle pi over 6 is in degrees? What about pi over 3? Pi over 2? Okay, remember that pi over 6 is 30 degrees. Pi over 3 is 60 degrees, and pi over 2 is 90 degrees. You're supposed to have that memorized in Chapter 4, so if you haven't done so already, please make sure you make a point to memorize it now. If we were to draw a pi over 6, pi over 3, and pi over 2 triangle, it would essentially be a 30, 60, 90 triangle. 30 would be the pi over 6, that's the smallest angle. Pi over 3 would be your 60 degrees, that would be the bigger angle, and then pi over 2 would be your 90 degrees. Do you remember your side lengths that coordinate with those angles? Across from the 30 degrees, which is pi over 6, the length is 1. Across from 60 degrees, which is pi over 3, the length would be root 3. And then your hypotenuse would be 2. Do you remember what angle in degrees corresponds to the radian pi over 4? For the pi over 4, and pi over 2 triangle? That's your 45, 45, 90 degree triangle. So if we were to draw that, oops, this one's going to look a little more like an isosceles triangle. Okay, so this would be pi over 4. That's the same measure as pi over 4. Those are your 45, 45. And then your 90 is your pi over 2. The side lengths of those are 1, 1, and root 2. This is all material that we learned in Chapter 4 and that you were supposed to have memorized. So again, if you haven't memorized it yet, make it a point to do so now. We also studied quadrantal angles in Chapter 4, which we're going to need that concept for this lesson. Quadrantal angles are angles that fall exactly on the x and the y axis. So 0 radians, pi over 2, that's 90 degrees, pi, 3 pi over 2, and then 2 pi or 0. You need to know the coordinates for those angles. The coordinates are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Remember that instead of x comma y, we use cosine comma sine for our coordinates. So the x value is the cosine and the y value is the sine. And remember that tangent is sine over cosine. Lastly, it is important for you to make sure that you remember the signs of the ordered pairs within each quadrant. Plus plus, minus plus, minus minus, and plus minus. That's for your x and your y values. Remember that all of your ordered pairs, instead of being x comma y, they are cosine and sine. Okay. In this lesson, we are asked to solve an equation for the domain of 0 to 2 pi. Domain refers to x values. Range refers to y values. That you learned freshman year, hopefully. So the answers that I give for all of these problems for x can only be between 0, so they could be exactly 0, up until 2 pi, which is a full rotation. So this has to be within one full rotation, one full circle. Make sure that you pause the video and write down the directions for these problems. Make sure you write down the full directions. Solve each equation over the domain of bracket 0, comma 2 pi. Provide a diagram and give it answer in exact radians. Remember that brackets mean that you can include 0, but parentheses means that you can get really close to a full to 2 pi, but it can't hit exactly at 2 pi. That's what the parentheses mean. Okay. Number 1. The sign of what angles in radians, the sign of which angles give me a half? Well, first things first. Sine is the y value of an ordered pair. So if you look over here where we had sines, sine is the y value. Sine is positive. You see how they say sine has to be positive a half? Sine is positive. Remember, sine is the y value. Where is the y value positive? Which quadrants is the y value positive in? Quadrants 1 and 2. Now what we need to do is we need to say, okay, well, what reference angle gives me a sine of 1/2? Remember that sine is opposite over hypotenuse. Which triangle, 30, 60, 90, or 45, 45, 90, would give me a sine of an angle that would be 1/2? Well, let's take a look. Can I obtain opposite over hypotenuse of 1/2 from a 30, 60, 90? Yes, if I use pi over 6, which is your 30 degrees. So sine of pi over 6 is opposite over hypotenuse would be 1/2. So my reference angle is pi over 6. I like to write that down. So reference angle is pi over 6. Remember that sine is positive in quadrants 1 and 2. So pi over 6 here as a reference angle. Let me zoom in. And pi over 6 as a reference angle here. Okay, so which angles have a sign of opposite over hypotenuse? I'm filling in my lengths according to my 30, 60, 90, aka pi over 6, pi over 3, and pi over 2 triangles. It'd be the angle that has a reference angle of 30 degrees in quadrant 1, and the angle in quadrant 2 that has a reference angle of 30 degrees. Because they want the answer in radians, remember that in radians, this is 0, aka 2 pi. So this would be 1 pi over 6. And then this angle counts starting from 0 is, remember this is 1 pi. How do you write 1 pi with a denominator of 6? It'd be 6 pi over 6. So if the reference angle is pi over 6, you're going to ask yourself, okay, well, subtract pi over 6 from 6 pi over 6, and that would give you 5 pi over 6. So x is pi over 6 and 5 pi over 6. Another way that I can explain this to you, and I have explained it before, is as soon as you know your reference angle is pi over 6, cut this half of the circle into 6 parts, 6 equal parts. So this is 1 pi over 6, 2 pi over 6, aka pi over 3, 3 pi over 6, aka pi over 2, 4 pi over 6, 5 pi over 6, and 6 pi over 6. Sorry, 4 pi over 6 reduces to 2 pi over 3, and then 6 pi over 6 reduces to pi. So remember what I said, that the two angles that have a reference angle of pi over 6 were 5 pi over 6 and 1 pi over 6. Go ahead and pause the video, rewind, and rewatch this problem to make sure that you understand it. Okay, number 2. Cosine of what angle in radians equals root 2 over 2? Can we obtain a cosine that's root 2 over 2 from a 30, 60, 90 or a 45, 45, 90 triangle? Now remember, we're supposed to be using radians, so you want to use these triangles, right? Which of these triangles would allow me to use an angle so that the cosine of it is root 2 over 2? So you're going to start with the first triangle, right? Let's say you choose pi over 6. If I do adjacent over hypotenuse, which is what cosine is, so cosine is adjacent over hypotenuse. If I use pi over 6, adjacent over hypotenuse is not root 2 over 2. What about pi over 3? Adjacent over hypotenuse. Nope, that gives me 1/2. So it can't be this triangle. Let's try this guy. Adjacent over hypotenuse. Yeah, 1 over root 2 if I rationalize it. One over root 2, if I rationalize it, gives me root 2 over 2. So this means that the reference angle is pi over 4, 45 degrees. Why? Because the pi over 4, no matter which pi over 4 you use, if you use adjacent over hypotenuse, either this one, adjacent over hypotenuse, or this one, adjacent over hypotenuse, you get root 2 over 2. So the reference angle is pi over 4. Now, cosine of the angle has to be positive. So if you think back to your quadrants, cosine is the x value. Write yourself a little note. Cosine is the x value. Of an ordered pair. Cosine is positive in quadrants 1 and 4. Remember this was plus, plus, and this is plus minus. Cosine is the x value. Okay. So we're looking at angles with a reference angle of pi over 4 over here and pi over 4 over here. So as your reference angle. Now remember, they want our domain is from 0 to 2 pi. They don't want any negatives. So if your reference angle is pi over 4, you can cut each half of the circle into 4 parts. So this would be 1, 2, 3, 4. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4. Now remember, 2 pi over 4 reduces to pi over 2. And then 4 pi over 4, which reduces to pi. So this angle, let me highlight it. This angle is pi over 4. The cosine, I'm starting to build my answer here. The cosine of what angle is root 2 over 2? Well, pi over 4 would give me, I'm going to fill in my sides. Cosine of pi over 2, 4 would be adjacent over hypotenuse, which if I rationalize it would be root 2 over 2. But this angle down here is also a solution. This guy right here, okay? Now that angle started from 0 and it went around to here. We cannot go from 0 and go down pi over 4 because the domain includes only positive values. So I'm allowed to go around the circle until the full rotation. So what angle is that? Well, if you keep labeling your pieces, so if you keep cutting each half of the circle into 4 parts, and keep counting from here. So this was 4 pi over 4, 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2. That's your 270 degrees, and then this would be 7 pi over 4. So your two solutions are 1 pi over 4 and 7 pi over 4, because both of those have a reference angle of pi over 4. One pi over 4, that would give me this guy, and then 7 pi over 4, that would give me this guy. Both of those have a reference angle of pi over 4. Now, give me 1 second because I got to clean this up a little bit. The reference angle for both of these is pi over 4, remember? The side lengths were 1, 1, root 2 for that triangle. For this one, it was -1 and root 2. But both of these angles, 1 pi over 4 and the one that went down or up and around, 7 pi over 4, if you take the cosine of those angles, so cosine is adjacent over hypotenuse. So adjacent over hypotenuse for pi over 4 is 1 over root 2, rationalizes to root 2 over 2. That's what the problem wanted. Or 7 pi over 4, adjacent over hypotenuse is still going to give you 1 over root 2, which rationalizes to root 2 over 2. So both of these angles are the ones that are going to give me a cosine that's positive root 2 over 2. Okay. Tangent of x equals 0. In what quadrant is tangent positive? Well, remember tangent is sine over cosine, aka y over x. So think of your ordered pairs. If tangent is y over x, then I want the quadrants where both x and y are positive or where they're both negative, because positive divided by positive, or y divided by x is positive and y divided by x is positive here. So we're looking at those two quadrants. Which triangle, 30, 60, 90, aka pi over 6, pi over 3, triangle, or pi over 4, 45, 45, 90, would allow me to get a tangent of 0. Well, tangent is opposite over adjacent. Remember, we learned tangent two different ways. We learned it as sine over cosine, but also as opposite over adjacent. Okay, well, let's see. Let's look at the 30, 60, 90 triangle. Would that one, if I use opposite over adjacent of any of these angles, would it give me 0? Let's try the pi over 6. Opposite over adjacent. Nope. Pi over 3. Opposite over adjacent. Nope. Try the pi over 4, the 45, 45, 90. Opposite over adjacent. Nope. Opposite over adjacent. Nope. So none of these triangles are going to give me opposite over adjacent. That's 0. That means that we must use the quadrantal angles then. Which of these, so remember, opposite over adjacent didn't work with any of the triangles. So if it doesn't work with the triangles, that means it's a quadrantal angle. Quadrantal. It means it lands exactly on the x or y axis. Which of these ordered pairs, if I take y and divide it by x, would give me 0? There's two of them. There's this one and this one. Sorry, those would give me undefined. I don't want those. As I was saying it earlier, I was like, oh snap, I did it wrong. So we want y over x to give me 0. The ones I had chosen earlier, like 1, 0, if I took, I had picked this one before. If I had picked 0, 1, y over x would have given me undefined. So I want the ones that are going to give me 0. So y divided by x has to be 0, not undefined. That's this guy and this guy. Again, I misspoke earlier. I had picked 0 and 1, but if I take the y and divide it by x, that would give me undefined. And I don't want tangent to be undefined. I want it to be 0. So the two angles that are solutions to this are 0, so the angle that's on the x-axis and hasn't rotated at all, and then the angle that is half a rotation. So let me draw it without the coordinates. So 0 degrees, this would be 0. Remember, this is 0 and 2 pi. This is pi over 2. This is 1 pi, and this is 3 pi over 2. You guys need to make sure you understand that those are always the quadrant angles. So this is a solution, 0, and this guy over here, pi. Okay, what I would like you guys to do is to do the next 3 problems by yourselves and then check your answers. So pause the video, try the next 3 problems, then unpause the video to check your answers. If you need help, please let me know and I will help you. Okay, pause the video now. Actually, not yet. Hold on, let me show you the problems. So try these next 3 problems. Here we go. Okay, here are the next 3 problems. Pause the video now and then unpause the video to check your answer. Please no cheating. Make sure you're trying them on your own. Okay, pause the video now. Okay, hopefully you tried 4, 5, and 6 on your own and got these solutions. If not, take a look at the hints that I've given. Remember that to find the reference angle, you have to look at your 2 triangles and figure out which ones would give you, for example, sine is opposite over hypotenuse. So this comes from a 45, 45, 90 triangle, which is reference angle of pi over 4. Tangent is opposite over adjacent. That came from a 30, 60, 90, pi over 3, pi over 6, pi over 2 triangle. The reference angle is pi over 6. Think about it. 1 root 3 and 2. If you take the tangent of pi over 3, that's opposite over adjacent. I just realized I labeled the wrong angle. So pi over 6. If you use pi over 6 as your reference angle, opposite over adjacent would be 1 over root 3, and if you rationalize it, you'd get the root 3 over 3. I was using pi over 3 earlier and paused the video myself because opposite over adjacent would not give me root 3 over 3. So you have to use your 30, 60, 90 and your 45, 45, 90 triangles till you find the right combination and the right angle that would work. So here would be pi over 6. Okay, so go ahead and use the hints. Send me a message through Remind or on Google Classroom, and I'll do my best to help you and set up a time to answer any questions that you have. All right, guys, have a good day. Bye. Bye.